right, so let's go ahead and begin. So thank you everyone for attending this webinar from Pavilion Data on boosting SQL Server performance while doubling your VM density. Joining us today is David Klee from Heraflux, as well as Walt Hinton from Pavilion. This presentation is being recorded. If you do have any questions, please feel free to go ahead and enter them into the chat box, and we'll go ahead and answer them either live during the presentation or at the end of the presentation. And with that, I would like to go ahead and introduce David and Walt.
Sweet.
Hello, everyone. And I'm going to let David more or less drive. We're trying our very best not to make this a commercial for Pavilion. However, I do reserve the right that there is a slide that is a commercial for Pavilion. But the meat here comes from David Klee. So David, why don't you just take it away?
Perfect. My name is David Klee. You'll find I am a diehard geek with this stuff. I am the founder and chief architect of Heraflux Technologies and the founder of Sequilibrium Education. My contact info is up on the screen there, and I'm lucky enough to be a Microsoft Data Platform MVP and a VMware vExpert. Basically, I have a lot of fun working with companies all over the world, playing with some really big database servers on some really big equipment. I have a lot of fun with this stuff. Performance, availability, and really platform license optimization, reference architectures, things like that. We just have a blast with this stuff. So let's get rolling here. If you are a DBA on this call, chances are you don't like your storage admin. And if you're a storage admin or a virtualization admin on this call, chances are you don't like your DBAs. Well, I want to get to the bottom of that by exposing how storage, the platform, and the databases work together, and a lot of times don't play well together at all. And it ends up in a finger-pointing match, a shouting match sometimes. It's not fun. So from a DBA perspective, the single biggest challenge we have is, here's me, here's my database. My users in the application hit save. Simple, basic command. Okay, so the time it takes to get that command hardened onto disk and back to the application is one of those things where it's not good. There's so many bottlenecks in the entire stack that you end up with end users that are they're really upset with the application performance. You've got DBAs that see this stuff holding it back, and it could be database design, could be platform, could be all the queues and bottlenecks in between. It gets really tough. And that's at a micro level. Zoom out. Take a look at what happens when you have a lot of users. So let's say, one user, happy database, no big deal. Second user, no problem. This thing can handle it just fine. Okay, well, everything is fine. We've got normal usage patterns. And then all of a sudden our company just went viral, but the database is holding back the business. This is not fun. And this is a situation that I know a lot of you are in. The symptoms of this get really interesting. So let's just say this is your infrastructure stack. So if you work from right to left, you've got enterprise storage, you've got LUNs, you've got interconnects, you've got physical machines. They're probably virtual machines for your SQL servers at this point. You got your database, you got the data files on disk somewhere. And what you get woken up in the middle of the night with is long IO alerts manifested through statistics called disk stalled. And it's off the charts. It's not good. It's terrible. And then you go look at whatever monitoring you have at the operating system, and it's showing still really bad. And then you go and talk to the storage admin, and things there aren't good, but it's nothing like what you're seeing at the database layer or the operating system. You got to watch out, because one, this is where people get into trouble. This is one of those areas where, no exaggeration, I was in a meeting. These exact stats came from that meeting. It was such a heated argument between the database administrator and the storage admin that the storage admin picked up a chair and threw it. And I don't know if you've ever picked up a Herman Miller Aeron, but those things are not light. So that's pretty serious. These are real situations. These are real problems. It's not fun. So let's start with the data platform itself. This represents your normal data platform. So you've got enterprise storage, interconnects, hypervisors, HBAs, all kinds of compute in the host, and you got your virtual machine, a number of disks, and life is good. Well, check this out. With all the silly defaults all over the place, you could have bottlenecks at the disk pool in the SAN. You could have bottlenecks with cache memory or the controllers inside that SAN. You could have bottlenecks at the interconnects or the uplinks or individual port maximums or CPUs in there. You could have the same bottlenecks on the interconnects on the physical machines. There's at least 3 major queues inside the hypervisor, none of which are set for fast storage. And then the controllers at the virtual machine and the virtual disk layer. And then you hit inside the operating system and then the database engine. And then when you zoom out, that's not just one machine. You got a bunch of these. All of these different bottlenecks will manifest with major issues. And then when you just look at the database side, so here's a database, here's a data file and a log file. Most of the time we've just got the one because that's what the vendor gave us. You got bottlenecks of the database engine. You have bottlenecks of the concurrency for the metadata. You may even have bottlenecks inside getting into that data file. This makes unhappy DBAs. This slows the business down. Nobody needs that. The thing that matters the most is the speed that it takes to commit that change to the business data to disk. And you literally got to work all the way through this entire stack and back. It's kind of like you just bought a car with square tires and let's just say a 1-gallon gas tank. You can change the tires, but now you got the gas tank problem. You start working through the concurrency challenges behind this stuff. And if the time that it takes to commit a transaction to disk is at a micro level, it can have really big implications. It's called lock escalation inside SQL Server. So what happens is an operation operates on a row of data. Well, if that lock starts to escalate because things are taking more time or it's a bigger operation than people realize, you can end up with a page lock, and a page is 8 kilobytes of data on disk that may contain a lot of data. Well, go further. It can hit a table, and if an entire table is locked, that's a big deal for a lot of these high demand systems. Sometimes it can even lock an entire database. This is the challenge. With SQL Server and arguably tons of other relational database engines out there, readers and writers will block other readers and writers with the locks on these objects. Now, there's a few things you can do to minimize the impact of readers, but writers will still lock. And this doesn't even mention the database code, the database design, the table structure, all the bad logic that's been inherited for decades. It's a challenge. So, you've got the table design, metadata access, all this stuff can start to act up. Now, again, you may not be able to see the stuff directly, but the symptoms are latency, the time that it takes to commit that transaction to disk. So if you take a look at the infrastructure stack here, literally there's storage, there's interconnects and networking, there's physical server, the hypervisor, the virtual machine architecture, the operating system. If you're running containers, that too, the SQL Server instance, then the database, and really you go into the file group and then the data file. The symptoms manifest at the top and get bad closer to the top that you get. You got to have good monitoring at each layer, and every layer's point of view is completely valid. Don't let anybody ever tell you that this set of tooling is inaccurate or bogus because of the fact that it's a VM or all this other stuff. Every one of these is valid from its point of view. The bottlenecks will tend to magnify upwards, and if you're looking at 1 or 2 of these data points, you may not see everything. So people always ask, why didn't we catch these bugs in testing? Well, it sounds like it's an easy question, but it's really not. To paraphrase a very good friend of mine named Kellen, the clothes that fit your child when your child is 3 do not fit when your child is 13. These are living, breathing, evolving databases. You've got things like application upgrades, more data's getting loaded, more users are on there, you name it. New version of the database engine, all sorts of things that were best practices 10 years ago may not be anymore. You're guaranteed to hit different points of inflection and different bottlenecks at the different stages of database growth and usage, not just in the database, but with everything underneath it. And literally, when you do a bottom-up remediation process, you're hitting the storage, then the interconnects, physical server, all the way into the database access patterns. If you don't do it in this order, it's kind of like saying, well, I've got a straw connected to a fire hose. Well, I'm going to change it to a garden hose. there's still a bottleneck there. You got to watch out for this stuff. So now we're going to take a bit of a detour. Why is this stuff so important? SQL Server and memory and storage have a really interesting dichotomy in there. If you've been managing SQL servers for a long time, you know SQL Server has got an incredibly large memory footprint, but you may not have really asked the question, why? It's really simple. The large memory footprint of a relational database engine is a storage read cache. That's it. It's not a write cache. You can't do that. You have to harden the data to disk as part of the ACID properties of a relational database engine, but it's simply a storage read cache. The working pretense of SQL Server, and really a lot of the other databases out there, all working data is in memory, because when this stuff was produced, 20, 25 years ago, memory was and still is faster than primary storage. The database administrators even have a setting here. This is why the database engine eats so much memory. As part of basic setup, they can say the database buffer pool, this read cache, can eat X number of % of the operating system memory. And usually you leave, 80, 85% for SQL Server, leave 5, 10, 15, 20% for, everything else. And this is why the memory footprint is big. It doesn't change. It's going to hold on to it. And here's why. So let's just say I run a command that says select star from table users where username equals David Klee. No big deal. Okay. Is that data in memory? Is it in that buffer pool? If not, we need to read from disk. Load it into memory, no problem. But what if there's other stuff in that buffer pool already and there's no free available room for this thing? Okay. Do we have enough free space? If so, cool. Yeah, load it up and process it. If not, find the data that's old that I haven't accessed in a while, kick it out of the buffer pool, make room for the new data, and then load it from disk. Okay, well, the second you need to reread that data that you just kicked out, you're going back to storage again. And the cycle continues. And this is why SQL Server has got such a big memory footprint. And honestly, if you're looking at things like vRealize or a lot of these other stats, you're going to see a significant amount of memory churn there. This is why. There are some metrics that you can use to calculate and see how long this data is sitting in there. It's not exposed at the operating system level. SQL Server actually hides what it's doing with this stuff from the underlying OS. But there are instance level WMI metrics such as page life expectancy and buffer cache hit ratio. These are things you can sample. You don't see it in the OS, but this is SQL Server's perspective on how much it's churning memory. In a lot of cases, if the storage layer is really slow, more memory will cut down on the amount of reads from disk and make the operation faster. But there's some interesting stuff there. We'll talk about that here in a little bit. Okay, we're going to start at the bottom of the stack here. We're going to hit enterprise storage. So if you've been seasoned in IT, you'll know that these things came from very slow spindles. Long time ago, they're still there for capacity at this point, but I don't like spinning rust. So now we're going to hit solid state drives, and there's a SATA interface, SAS interface, and it's basically the same controller as the spindle drives, but you put flash underneath. So we had this legacy architecture for how to access the data that was actually on the SSD cells. Now, more recently, the powers that be, whoever they are, decided that this format was not good enough. And since flash cells were so darn good at random IO, they changed the storage format to what's called non-volatile memory express, or NVMe. It's extremely fast for random disk access patterns, which is amazing because when you start looking at things like highly virtualized environment or large relational databases, it's an incredibly random pattern, especially when you put this stuff together. Now, there's bottlenecks in every single IT stack. This is the hard part. 2021, today, the image on the screen of that NVMe drive, that's not the bottleneck to performance anymore related to enterprise storage. The new bottleneck is the controller, the thing that says, where is the data that I'm asking for on which drive, and the path to get there. That's tough. This is honestly why so many of these really high-end SQL servers will run local attached storage, because the controllers at the SAN were so underpowered or overwhelmed, depending on the workload, they just couldn't keep up. Local attach, you work through those things. You get a really beast of a local controller and it's local. The problem there, that's a single point of failure. Me as a DBA that specializes in availability architecture, I don't like single points of failure. It's not the most fun. So that's been the dichotomy with this stuff. We've had to manage and balance this stuff. The controllers themselves have CPU, they've got cache memory, they have to deal with metadata, they have to deal with disk integrity. Sometimes they can't keep up. And when you're looking at a more recent SAN, but not something that's really built for today, you're dealing with a two controller architecture where they may be, I hate the phrase active, but they could be multiple active, where one is doing all the work and the other is accepting read activity and sending it over to the other controller, or it could simply be sitting there in a standby mode. So the bottleneck at that point is the controller. It's literally the thing that's saying, where's my data, how to go retrieve it, and how to send it back to the end user. That's the tough part. Now, you start hitting some really current stuff, and now you're dealing with multiple active controllers, multiple disk pools, because the bottleneck internal to these things has now shifted onto the PCI Express backplane. So they have to be engineered properly. And we're talking multiple gigabytes a second here, but this is how fast this stuff is at this point. Now, do not forget the interconnects, the paths to essentially get from your enterprise storage to wherever you're talking to. Just please tell me that your server room does not look like this. And this is a real photo that I took at a customer site and they let me show this, as long as I don't tell you who they are. And that's fine. But when I saw this, I really wanted to come back the next day with either a pair of hedge clippers or one of those little chainsaw things and just say, start over. This was not good. Okay, Walt, I'll let you talk through here.
So to David's point about controllers and bottlenecks and interconnects, there is a better way. And it's based upon not fiber channel, but Ethernet. And if you look just at the cost characteristics of sort of next generation fiber channel, compare that with 100 or 200 gig Ethernet, there's really no comparison. And from a roadmap perspective, I think we've all determined that Ethernet is the future. But around those controllers and around that PCIe bus, Pavilion has taken a different approach. And we built our storage platform based upon the fastest thing in the data center, which is the network switch. So we have a pair of 6 terabit per second PCIe fabrics inside our storage platform. We also then connect those via NVMe SSDs. So David referenced, NVMe is the hot new thing. I've been working in that industry. Even before NVMe was a standard, we were selling PCIe cards, and there is no comparison. The latency, the throughput, the endurance, everything about it has become better. But the next bottleneck then is the controllers. So Pavilion went about it in a very different way. Rather than a dual controller architecture, which is what kind of the industry is standardized upon, we offer up to 20 storage controllers. You see the slots on the right-hand side, there are actually 10 line cards. Each line card has dual controllers in it. You don't have to buy them all at once. You can start small and scale as you need, but a very different approach to tackle this problem of controller, concurrency, database latency, and giving you the ability, the flexibility, sort of redefine how you offer or deliver SQL Server services. The next piece is the connectivity. So I'm just kind of already at the point, Ethernet is the answer. Use Ethernet and NVMe using TCP, use Ethernet and NVMe using Rocky for the lowest latency. And with Pavilion, each of those line cards that I referenced on the previous comment, we can have up to 40 100 gigabit per second Ethernet interfaces, or 10 at 200 gigabit. And that's Ethernet, or in some cases, people are interested also in InfiniBand. Now, the last point I want to make here, and then we'll stop the Pavilion commercial, is that all of this fits in 4 rack units. So yes, you have competitors out there who say, oh, I can deliver 90 gig per second of throughput. In what form factor? We do that in 4 rack units. So extremely high I/O per second, extremely significant throughput, and very low latency.
Cool. Fun toys. Toys that make my life better. Okay. So we've hit the storage. Let's move up just a little bit. So now we're talking about how does all of this connect into the physical machine? So if you're still dealing with fiber, host bus adapters. 32 gig is kind of the new standard. A lot of folks haven't gotten there yet, but when you start hitting stuff this fast, the bottlenecks change. Again, we're talking about PCI Express backplanes. We're talking about port switching rates, multiple cards, multiple ports. Now, there's stupid defaults inside all of this stuff. No exaggeration. These things, we're dealing with some of the fastest storage on the planet. The default queue depths in these values are 32, maybe 64. If you've got really solid storage, these queue depths are ridiculously low. It's akin to buying that Italian sports car with, again, square tires, 1 gallon gas tank, and first gear only. You're not getting far. These need to be adjusted. So work with your vendors and go look to see if those defaults are set too low for the kind of storage that you have. Now, when you're dealing with networking, 40 gig and 100 gig, that's kind of the new standard. Same exact stuff. PCI Express backplane, throughput, all this stuff. RDMA over converged Ethernet or Rocky. This, in my opinion, is some of the fastest networking on the planet. It essentially allows the lowest possible latency end-to-end. This is not a traditional network adapter. It does require a little bit of fancy drivers and nice adapters, but this is the future of this stuff. And Walt? Oops, you're still on mute there.
Muted, sir.
There you go.
So a few things to consider here. If you are a current iSCSI or even fiber channel user, these are some points of reference that Pavilion did with our friends at NVIDIA and with our friends at VMware. And comparing NVMe Rocky to iSCSI using the same set of servers, the same set of Pavilion hardware, the metrics are just radically different and radically better. So David, why don't we look at reads and read latency? Go ahead and click that. 2x read IOPS at 47% of the latency. So latency, concurrency, they matter. Let's look at the next metric. The next metric is, how do I feed the beast? Well, it's all about write IOPS. And here you see, again, this is just NVMe Rocky to iSCSI, nothing, radical, no special changes or anything. 1.5 times the write IOPS at 61% of the latency. So what does this mean for you? Let's click the next button here. It means I can run 2 times the number of virtual machines. I can probably change how I license things, how much memory I use in servers. So I can cut my cost by 50% while doubling the number of VMs. Let's look at the next metric. It means I can run more virtual machines. And looking at these latency numbers, I can do that with half the latency. So one more click here, David. It means I can do twice the I/O at half the latency on the same number of VMs. So what does that mean for you? David, why don't you talk more about kind of the next steps here?
You bet. This means a lot from a SQL Server perspective. And as we continue to work our way up the stack, I'm going to kind of swing the conversation to talk even more about that. So yeah, there we go. Okay. If you're dealing with blades, please watch the blade enclosures. These things get even more interesting, especially if you're dealing with fake network adapters being presented to real blades. An example of this, Cisco UCS, the FCOE adapters. No big deal. The default queue depth is 20. That's worse than taking a fire hose and trying to connect it to a straw. That's terrible. Please go change this. It's in the FC adapter policy, usually for either VMware or Windows, wherever that's at. Now, let's work our way up a little bit. So for all of you who may be from the data space, everything that a virtual machine does and is boils down to two things. You have compute resources, CPU, memory, network disk. All the hypervisor really does is provide resource scheduling queues for these compartmentalized virtual machines to get access to the compute resources. It's that simple, in theory. What you end up with are scheduling queues. And then when you have a lot of activity in there, these things can start to stack up, especially if there's some really silly bottlenecks from either bad defaults or just overwhelming some of the design. So when you hit the virtual layer, and this is VMware Hyper-V, quite frankly, all this stuff applies to every other hypervisor out there, just maybe change some of your buzzwords. There's some very specific challenges with this. Virtual machine overcommit and the concurrency to get through these scheduling queues as fast as possible. Then there's the storage queues, and then host memory density. And it seems like the memory density is kind of out of place there, but it really isn't. And I'll explain more about that. Now, first of all, if you change any of the queue depths in any of the interconnects inside your physical machine, change this inside the VMware driver. Check with the device manufacturer. There's a lot of good examples. VMware's actually got a KB article out here. So, let's say it's Cisco UCS driver, change it here. Emulex, QLogic, Mellanox, those sort of things. They probably need to have that value reflected as well here. This one is VMware specific, unfortunately. Haven't found any info for Microsoft Hyper-V on this yet. Now, iSCSI, this is VMware and Hyper-V. The default queue depth is 128. So again, if you're on really good storage, this is probably too low. So as with always, check with your storage vendor for recommended settings, test and validate everything. But there is the example of how to go change this on VMware. Their knowledge base article says go from 128 to 64. That's really silly. A lot of times we're going to go 256, sometimes a lot higher, depending on the storage platform that you've got. So that cleans up that layer. Now hit the next layer. And this one is one that is poorly understood out there. It's a value called disk.sched numrec outstanding, or DSNRO. So say that 3 times fast. What you end up with is a really interesting concurrency challenge. And this is part of why a lot of these companies will tell you to do one virtual machine per SAN LUN. I don't necessarily agree with that, but this is an interesting little bottleneck in here. So I joke that VMware is the center of their own universe because a virtual machine and its dependent disks are called a world. If one and only one world exists on a VMFS formatted data store, the queue depth at that host to that data store is inherited from what this virtual machine sends to it. So if you're, I'll talk about this here in a minute, but if you have multiple controllers, each with higher queue depths, it could be all the way up to 256, maybe even close to 1,000. Not a big deal. Now, what normally happens, we're not doing one-to-one. That's a waste of time. People have a lot of stuff to do. It's a lot of micromanaging. If more than one world exists on that data store, the queue depth at that host to that data store drops to a value of 32. Silent. Nobody sees this stuff. It is an immediate bottleneck for anything that is even remotely demanding with storage. This is a problem. You can adjust this higher, and I highly recommend it. There is a link on the screen here that'll take you to a VMware knowledge base article. This is one of those settings that I've been tuning all the way back to at least 5.0, if not sooner. It's common. Nobody's ever heard of this. It's one of the biggest problems with storage queuing. Okay, so that's bottleneck number 2 in the hypervisor. Now let's work our way north a little bit more. What a virtual machine actually is a representation of physical devices that you would normally connect to a physical server. It's a CPU, memory, hard drives, NICs, things like that. The virtual machine, you have the same thing. The two that we really hit regarding storage performance is going to be the virtual disk and the virtual disk controller. Now, the start of the controller, by default, you end up with the LSI logic SAS, and this is the silly default. The hypervisor does queuing, not just by controller, but by a number of controllers, by virtual disks connected to those controllers. So what we need to do is make sure that we have the appropriate number of controllers for your workload, as well as the right type. And sometimes that depends on the underlying storage. So there's a few types on here. If you are on Hyper-V or VMware, the default is the LSI logic controller. Nothing fancy about it. It's there for compatibility. If you're on VMware, they wrote one called the VMware Paravirtual SCSI controller. If you're on vSphere 6.5 and above, you now have an NVMe specific controller. You get with VMware, or actually with any of these, you get up to 4 total SCSI controllers. On VMware, you also get an additional 4 NVMe controllers. So if you're dealing with the LSI SAS controller, you can see it inside the device manager. Here, if you just expand out hardware, go to storage controllers, you'll see it pretty simple. It's got a default queue depth of 32 concurrent IO operations. So think about everything that we've been talking about. This is going to hold this VM back. Really, really simple. This is the default for VMware and Hyper-V. And if you're on Hyper-V, unfortunately, this is your only option. You can now just deal with more than one of those. If you're on VMware, this one is specific just to VMware. It's a Paravirtual SCSI controller. Default queue depth is 64. With the registry value, it's overridable up to 254. And there was a recent update that actually said per device, it's now up to 1,000. So something to keep in mind. The driver updates now are available through Windows Update. So I use this religiously for anything on VMware. More recently on VMware, they came up with the non-volatile memory express controller, NVMe. So instead of one queue with a queue depth of 32 or 64, you now have 16 queues, 15 of them you can use. The maximum queue depth is 256, but you get an additional 4,000 pending commands per controller. If you're on NVMe underlying storage and you have a fast enough interconnect to actually get there and take advantage of this, I would tell you to explore these. The only challenge, it's not part of the NVMe protocol to be able to expand hard drives. So one of the caveats with this one, if you go to grow a virtual disk, that growth it'll succeed inside VMware, but it will not show up inside that virtual machine until that virtual machine is restarted. And then the storage is there and you can expand the partition. So just a little nuance to keep in mind there. Now, the virtual machine performance layer gets really interesting. If you are part of the database space, you may not have seen a lot of the back end, but this is a pretty common chart that you can see inside one of the hypervisors. It is a shared everything. And on this chart, the orange at the bottom, that's a SQL server called DB01. The next one, that's a SQL server called DB02. And then all this other stuff, these are all their application servers and just basic stuff is just sort of sitting there. But you see SQL Server is the thing that's eating the most amount of IO and CPU and everything else in their environment. So my goal, I want to make sure that everything that we do is assigned the right amount of compute resources. So that way I am scheduling the least amount of activity to go through the virtual machine CPU and disk and memory schedulers. And if we do this appropriately, it's less for the hypervisor to manage, but we can maintain and sometimes even improve performance. So what do I mean by this? If we got a 12-core, 128 gig of RAM SQL server, and quite frankly, this thing is just hanging out, 5, 10, 15% busy, drop the core count. If you don't need all that memory, drop the memory itself. You can maintain performance and give it what it needs with a decent amount of headroom, of course, but you don't have to go crazy. This is one of the areas that is absolutely vital to maintain performance, because if we have less to schedule in the hypervisor scheduling queues, we can do more with less. If we have less to manage, that means the virtual layer has less to deal with, the operating system does, and SQL Server does. This is also a secret trick to minimizing your SQL Server license liability for this particular server. So how do we do this? I mean, this is a rhetorical question. How many do we need? How much RAM? How many CPUs? That sort of thing. So to start with, what are you consuming today? And there are a few good third-party utilities out there that you could buy to do this. And if you're interested, let me know. I'd give you some of my opinion on there. But if you don't have the budget or don't have any of these things already in place, you've already got something that can do this. You got Windows Perfmon. Windows Perfmon can grab operating system level and SQL Server level statistics using WMI. And if you're running SQL Server on Linux, there's a combination of sysstat and iostat. And let me know, I'll get you in touch with a guy that's got a really good set of scripts to be able to collect the same thing there. We have a how-to guide, and there's no contact info required for this. So feel free, go out there. It's just a PDF. This shows you how to set up Windows Perfmon for ongoing 24/7 collection. We love it. We use this religiously. We use it so much that I produced a PowerShell script that allows you to take the output from this collection, a BLG file, binary log, and load it into a SQL Server. Completely free, completely open. And this gives you the ability to put that raw data in a format that now you can do something with. So things like Power BI, T-SQL, Excel, I mean, whatever you want to use it. You've got the raw data and you can start to figure out how much of these resources do we actually need. It goes a long way. Now, once we figure out how much we need, now we got to figure out this concurrency layer at the hypervisor. The first thing that I look at inside VMware is a metric called CPU ready time. It's a measurement of how many milliseconds every 20 seconds that these commands are stuck inside the hypervisor scheduling queue, waiting to get through to actually grab this data. The easiest thing, multiply by 100% to make it a percent. Grab the sum divided by the number of cores divided by 20,000, because 20 seconds measured in milliseconds. That gives you the percent performance penalty on that virtual machine. If you're just looking at the per core value, cool. 100% times the per core total or max or average or whatever you care about there, divided by 20,000 milliseconds. That gives you the average percent performance loss, and that is powerful data. Now, if you've got access to VMware and you're looking at the real-time view, the readiness value is this percentage pre-calculated for you. The problem is that it's usually persisted only real-time, whereas the ready time calculation that I gave you will work if you go backwards in time. Just divide by the number of 20-second polling intervals in the roll-up window for VMware. Like the past day, there's 15 in there. So just take that value divided by 15. If you're on Hyper-V, same exact metric applies. We just call it something different. They call it CPU wait time per dispatch. It's measured in nanoseconds instead of milliseconds, but same exact thing. Take the average or take the individual CPU cores, divide it by basically the sample interval in nanoseconds. So if you're collecting every 30 seconds, divide it by that. And again, average percent performance loss. You're going to find that you can do a lot more with the hypervisor than you might think. Now, here's the challenge. If we're not paying attention to these things, if these things are just wonky and errant and not good, every one of these delays can mean that your in-guest performance metrics can be a little off because it's all based on a metronome. All of these are Windows differential counters. They're based off of a clock cycle tick inside the CPU that's 64 times a second, like a metronome. Just tick, 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 and it's measuring the delta between them. So if the hypervisor scheduling is acting up, that constant tick, tick, tick could be more like tick, 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 and it's inconsistent. And that can mean that your in-guest metrics can be off. And what that also means is CPU scheduling can slow down. And your storage latency can creep up because it's not linear anymore. And that's a real problem. And it's going to slow your virtual machine down. Sometimes could be 0.5%, 1%, no big deal. Sometimes we're talking 200%. And that's a really big deal. And this overhead can impact everything else on the host as well. So I call it noisy neighbors. You know, these are cranky machines and they can impact everybody around it. There is a way to measure this stuff. The ready time values, wait time per dispatch, these are key indicators. There's another one from storage that I really want you to know about. If you pick the virtual machine, go to virtual disk and go average number of outstanding read and write requests. It lists it by connected drive. This is an absolutely critical key value that says something in the hypervisor or that physical server is holding back my IOs. And you can see I ran a test here in a synthetic thing in my lab, and that spiked, and there's a value cap at 1280. It's not documented anywhere. If you see that, you are queuing like crazy, and your in-guest storage latency is skyrocketing as a result. You don't need that. Okay, next up, SQL Server. Whee! So here's your virtual machine. Here's what I normally see for a lot of these machines. You got a virtual machine, you got a few drives. DBA convention says I'm going to split out data, log, tempdb, maybe my SQL Server system databases, no problem. I got my data file. It's an MDF extension. I have a log file. It's an LDF extension. Cool, no problem. I got to understand what my workload is actually doing in there. This two-file setup could honestly be causing a hotspot inside the data file, and you end up with massive problems like table scans can lock the table. If you have commonly joined tables, you can have a metadata hotspot in there. If I'm scanning indexes and rereading data all the time, it could slow things down. I could have tempdb concurrency for things like sorts, or if I don't have enough RAM, it spills there and it's not fast enough and it can't keep up. It's not fun. Identify the hotspots inside your database design. And if you're a DBA out there, I know you know where they're at. Scale this thing out. You can do this. The default is a primary file group and then a transaction log. A lot of times, this is what we have. We have a primary data file and the transaction log. And if this thing is any bigger than a couple hundred gigs, that's probably going to be a metadata hotspot. So what I'd love to do, if you have any ability to do this whatsoever based on your database architecture, or if you bought it from a third-party vendor or whatever, just make this MDF for metadata only. No user objects in there whatsoever. Create more file groups. You don't have to go bonkers with it, but get it out of the primary file group. And then for each of these file groups, have multiple data files in there. If you do it for tempdb, why not do it for your databases? Spread out the workload. And what you end up with is the ability to say, now, this data 1 file group will have a lot of my customer data. Data 2 file group will have ordered data. And when I start joining these to figure out who's late on paying or where do I need to ship stuff, you spread this workload out. Now apply it to the infrastructure underneath. So now I've got virtual hard drives. Okay, well, can some of these live on the same virtual disks as others? Sure. Use your perfmon data, use your SQL Server DMVs to start to figure out what that distribution is. Spread it out, and then spread it out even more. Pick the controllers. Figure out where are my hotspots by drive, by controller. And a lot of times you're going to find that I need to spread out this workload to multiple paravirtual SCSI controllers, multiple NVMe controllers. Spread this thing out. Allow that layer of queuing to be less of a bottleneck. And then zoom out even further. So now I have my VMFS data store. I have the virtual disks. I have my SAN LUNs. Cool. So take a look at the storage queuing there. So now let's say I've got, certain disks. I'm going to scale them appropriately. I'm monitoring the disk queuing. I can do more than one per LUN. Cool. Just keep an eye on those storage queues. And then when you're dealing with modern storage, then you can say, well, multiple active controllers, multiple disk pools. And if you basically work from the top all the way through the entire stack, the infrastructure underneath is no longer becoming the primary bottleneck to both performance and virtual machine density. So now scale this thing out. Take a look. How many SQL servers can you fit on this equipment? Okay, we're going to take a bit of a detour again. SQL Server 2019 is the most current version of SQL Server out there. Forget developer, forget web. We're talking about production here. So enterprise and standard. Realistically, if you're dealing at this scale, you're dealing with enterprise. The licensing gets applied to the physical machine CPU cores if you're looking to achieve some pretty good license optimization. So let's just say, here's my host, 2 sockets, 16 core, 256 gigs of RAM per socket, no problem. If you start piling VMs on here and you don't give it enough RAM, guess what? You are wasting your SQL Server licensing. The lack of memory is holding it back. Okay. Well, what if SQL Server, the working pretense, needs all working data in memory, but the storage latency, that round trip time to get there, is incredibly low? What if your storage IOPS and throughput capacity are extremely high? What if you're managing your virtual machine CPU scheduling properly? What this means is your storage can keep up with the demand for your database activity with less virtual machine memory. I'm not making this up. So from a DBA perspective, this is going to sound like blasphemy, but realistically, do you need all of the SQL Server memory in the buffer pool to maintain performance? I'm not telling you to remove all of it, but I'm saying that from experience, if you remove some of it, if the storage can keep up, you don't need it all. What that actually means is if I reduce my memory footprint per virtual machine, but I watch all these other metrics to make sure all the performance is good, I can do more on that same physical machine. If you balance it properly, that's less virtual machine licensing because less physical machines need to be managed with this stuff at greater virtual machine density. So the goal here, more performance, less hosts that need to be licensed. So if I can do this, I can save some pretty serious money. And the storage itself enables this licensing. That's the most amazing part. So to wind this thing down, my goal with every bit of performance tuning that I do, I want to move the bottleneck in the platform to performance and scalability. I want to get it off the infrastructure and I want to get it onto the database code. Buy good storage and it moves the bottlenecks to the physical machine. Tune this appropriately and you're going to end up pushing the bottleneck into the database engine. Clean up the database design with the stuff that I was telling you about, and it moves the bottleneck into the database code. You can do this. Overcommit the virtual machine CPUs carefully. I'm not telling you to go crazy, but monitor those metrics. It means greater VM density, less hosts, and that means less licensing, which means you save a bunch of money and we all have an absolute party and we have a lot of fun with this stuff. So as with everything that I tell you, don't take my word for it. Question everything any of us tell you and test. Test, but you're going to find some amazing results with this stuff. Now, for everybody on the webinar today, if you are interested, everything that I talked about with the virtual machine tuning, we actually put together a full 8.5-hour on-demand video-based boot camp that gives you the deep dive of how to go through this stuff. Literally bottom to top, work your way all the way through the stack. It's good for DBAs, it's good for infrastructure admins. You can do this. And for you, because you're cool enough to sit through this long webinar with a lot of technical mumbo jumbo, we are giving you a 50% off promo code. So during the checkout process, just enter the word pavilion and it's going to immediately apply. So now I'm going to open this up to questions because I know that was an absolute fire hose with this stuff. So let me know, because if you have any questions, drop them in the Q&A window here.
Thank you everyone for attending. We appreciate your interest in the ability to improve your SQL performance and your VM density. So without further ado, we're going to just dive into some questions. First one is how does storage affect the overall performance, transaction commit time of SQL Server application? That's for you, David.
Sweet. Well, every single thing that changes in a database has to be hardened to disk before that transaction is considered complete. So the faster we can get it to disk and get it to stick, then we're good. Essentially, when we're changing all these streams of data, just little random bits all over the place, we need it to harden as fast as humanly possible. So the lowest possible latency really matters.
Thank you very much. Next question is, what are the common bottlenecks you encounter?
Oh boy. So outside of the rapid fire overview that we just went through in the last hour, quite frankly, people. I mean, the storage is almost always suspect when it comes to write latency. Beyond that, there's all these defaults everywhere. And then eventually, when you get to the top of the stack, it's going to be bad database design. My goal with tuning the infrastructure underneath a lot of these things, I want to make sure that the code is the bottleneck to performance eventually and nothing underneath it. A lot of times we can clean up a lot of this stuff, but then if the application is poorly constructed, we end up with, some optimal code. If we own the code, great. Otherwise, I just need to ensure that nothing else is holding it back.
Well, Pavilion can definitely help with write latency. We have the best game in town for that. Next question, please. How common is disk stall?
This is a big one. So SQL Server's got its own storage engine built into it, and pretty much any other relational database engine out there do the same thing. When we see differences of opinion in a lot of the telemetry, it's very common. I see this all over the place. Literally just this morning, I was looking at someplace. We've got 400 to 500 millisecond write latency as SQL Server sees it. Storage was showing 2 to 10. So when you get bottlenecks in the database storage engine itself, you'll see it, and the OS won't see it. And just like I mentioned before, it becomes a shouting match between the infrastructure folks and the DBAs, and nobody likes that. And everybody is always, I'm right, you're wrong. Sorry, everybody's right here from their perspective.
That's a tough one. Yep. Okay.
It is.
Next question, please. Why is latency important?
I need the data to move at the speed of business. If somebody's making a change or adding an order or ship something, I need it in there now. So the faster we can get it to disk, the less that operation is being held up and potentially holds up everybody else.
Sounds like a lot of our customers. Next question, please. Do you need a lot of memory for SQL Server, especially if it is virtualized?
Great question. Virtual or physical, SQL Server uses memory as a storage read cache. The working pretense is all working data is in memory. So if your memory footprint is too small, the database engine is dropping back down to disk considerably. If the storage can keep up, it's not nearly as important as you may think. And again, don't take my word for this stuff. They can actually reduce the memory footprint of the database engine, replay the same workload on there, and gauge the results. In a lot of cases, when we can get that latency to disk as low as humanly possible, we can chop 25 up to 50, sometimes even higher percent of memory off of that database engine, and performance is maintained or even improved just because of the storage speed.
So that's actually what Pavilion can help with, because if they reduce the latency, they'll also reduce the memory requirement for
Yep.
SQL Server. Is that correct?
That's correct.
And then by doing so, you can increase the number of SQL servers running on that host. And then subsequently, that will increase the overall density of the host, all without increasing your license costs, according to your
Exactly. Yeah, the licensing for enterprise can quite literally be 125,000 USD. So even if we can shrink the footprint of the physical deployment by one host, I mean, that's a serious amount of change saved. If you can do that 2 times, 5 times, 50 times, it makes you look really good, and you save the business a ton of cash.
Yeah, I've actually had a customer tell me that they were able to recoup the entire cost of the Pavilion investment in under 2 years. The amount of hardware and licensing costs that they saved. So
exactly. The way I joke is that at scale, SQL Server licensing, and it's not as bad as some other ones out there, but it's still not cheap. It can make the infrastructure underneath literally a rounding error on a budget line item.
Yeah, and though it's sort of a rounding error, it adds up. Is that if you also don't have to double your estate, you also save quite a bit of floor space and power and cooling, and everything is expensive now. I heard some crazy numbers from customers that like, how much are you paying for floor tile? That's absolutely insane. So,
yeah, I mean, literally rack space, power cooling, network switch ports, maintenance, time to maintain physical equipment, you name it, it saves it. And it all adds up.
That's good. Great. Thank you very much for that answer. Next question, please. Does a server VM density change when you implement high performance storage?
Yep, we just answered that one. But realistically, without good storage, you may be able to do 2-to-1 vCPU overcommit and maintain a reasonable density in there. With really good storage, we see double, sometimes triple, sometimes even higher densities than that. You
Yeah.
can't do that on inferior storage. You just can't.
Yeah, we have one customer that was able to get 24-to-1, but that's obviously, I think he was pushing the limit a little bit, in my opinion, but that was, he was touting his great ROI and TCO model. So,
Well, we let the numbers dictate how far we can push it, and we prioritize the VMs that actually need less CPU overhead. I think it's reasonable as long as you just gauge the net impact of everything on everything else.
yeah. So, thank you very much. Next question, please. Does fast storage benefit SQL Server availability groups?
Yes, availability groups are the flagship availability solution inside Microsoft SQL Server. The way it works, let's say I've got two in a pair. One is active, the second is a warm standby. When you do a transaction commit, it actually commits it to the secondary copy of the data first. Make sure that's hardened and then commits it locally. So again, if we have slow storage, we're committing remotely, it's slow, and now we just doubled that net impact. Plus, if you're not running, good networking equipment in Rocky, that time to get to the remote node and back is elevated as well. So you're looking at 2 to 3 times the speed or the duration to commit one of these transactions. So again, low latency storage, high speed networking, we commit that stuff a whole lot faster, and the performance overhead of the availability architecture is kept to an absolute minimum.
Okay, great technical question, great technical answer. Next question, please. Can you characterize how SQL Server performance benefits from Pavilion versus other NVMe SSD-based AFAs?
Yes, it is essentially better in many ways. You may be able to tune a local DAS array of NVMe drives to be very, very fast, very low latency, but there's still single points of failure. And that to me is arguably one of the greater benefits there. Plus, if you're doing that, you may have 1 or 2 local controllers, and you're going to overwhelm those pretty quickly. You have to get a pretty substantial architecture underneath it in order to scale that out. The Pavilion platform, you can go up to 20 active controllers, and we can scale that workload out and make sure that none of these components become a primary bottleneck. So we keep the overhead all the way to just the code, and that's where it should be.
Okay, great, thank you. One last question, and it is, why do I need a storage array when I have plenty of DAS storage available?
Couple answers to that one. Speed. We can do better. And it's resilient and redundant. I don't like single points of failure. Quite literally, if these systems shut down because of a controller failure or just, cache battery failure, anything like that, people could die. I don't like that. I don't like single points of failure in any of these things. And even if you're running availability groups in there, you're still at the mercy of a vendor to get that thing repaired. And with availability of equipment today, that's not going to be up and running in that 4-hour SLA that you just bought. It's going to be potentially weeks, maybe even months to get those replacement parts. So if we have resiliency in the underlying platform, we can focus more on allowing this thing to drive business rather than babysitting it.
Yep, that's great answer. Yeah, and Pavilion, everything on the chassis is enterprise class, and we even have some very unique capabilities like hot spare controllers that are unique in the industry, so that if there's any, even in the case of a controller failure, there's zero impact. So it's very excited for this webinar. Appreciate you joining us, David, and thank you
Anytime.
everyone for the audience for joining us today. And if you have any questions, please reach out. There will be a QR code at the end, and you can ask questions on our Pavilion LinkedIn page. And if there's any other follow-up questions, we're more than happy to reach out to you and do an individual session as at your convenience. Okay.
Awesome.
Thank you,
Thanks,
everyone.
everybody.
Take care.